Hello everyone to this lecture about expectation, variance, and standard deviation. Let's start by the expectation. The expectation, or sometimes called the expected value of a random variable x, is a weighted average of the possible values that x can take on. Each value will be weighted by its corresponding PMF. And the expression of ex is given by summation of xpx. For example, we can get, if we have the experience of flipping a coin, the result will be p of 0 equals 1/2 and p of 1 equals 1/2. In this case, the expectation of x will be equals summation of xpx, so it will be the first x is 0 times its PMF is 1/2 plus the x is 1 times its PMF is 1/2. So this first term will be 0 and this one will be 1/2. So this is the expectation of this experience. The variance of a random variable x with an expectation mu is defined by var x equals e, or the expectation of x minus mu, which is the expectation of x, so this is the same as ex. This term is squared, and we can get this expression of var x, which is simple compared to this one, from this expression. So this one will be it will be easier for us to compute var x from this expression rather than this expression. We will also define the standard deviation, which is the square root of the var x, and it is denoted by sigma, so it is sigma equals the square root of var x. And the standard deviation is very important because it allows us to measure the spread of x around its mean or its expectation, and also it is simpler to interpret because it has the same unit as x. However, the variance x doesn't have the same unit as x because it is squared. Here are some properties of the expectation and variance. So the variance is linear because e of ax plus b is ex plus b. However, the variance isn't, so the variance of ax plus b is equals e squared var x. We can verify this by using the expression of ex and var x. And also the expectation of a function of x, for example, we can call it y, is the summation of the value of this function times the PMF of each x. The expectation exn is called the nth moment of x is computed like that, and the ex is called the first ex that we have seen before, is the first moment of x. So here n is 1, so it is the first moment of x. Here we have the expectation of the distribution that we have seen before. So the expectation of the Bernoulli random variable is just p, and its variance is p1 minus, and we can get them from their PMF. The expectation of a binomial random variable is np, and its variance is np times 1 minus p. So it's just here the Bernoulli expectation and variance, but multiplied by n here and here. The expectation and the variance of Poisson random variable are the same, so which one is the lambda, and sometimes this lambda, the parameter of Poisson random, is called also the mean of the Poisson random variable, and it is its expectation and its variance also. And the expectation and the variance of uniform random variable are given by expectation of x is the a plus b, b is the biggest element in the interval, and e is the smallest one, so e plus b over 2, and its variance is b minus a squared over 12.